Okay, these 10 questions we will cover the sum of the interior angles of a triangle, parallel lines cut by a transversal, slope of parallel lines and slope of perpendicular lines, and looks like that's mainly what we're going to talk about. So let's look at number 1. Number 1 says quadrilateral MNQP is made of two congruent triangles. NP bisects angle N and angle P. In the quadrilateral N, the measure of angle N is 38 degrees and the measure of angle P is 140 degrees. What is the measure of angle Q? Okay, so I'm going to start by redrawing the quadrilateral. Oops. Okay, so I'm going to redraw the quadrilateral. And here we have M, N, Q, P. And it tells us that in the quadrilateral, the measure of angle N is 38 degrees. So this right here is 38 degrees. And then it says the measure of angle P is 104 degrees. So if I want to find the measure of angle Q, I want to look at the triangle. So I'm going to focus on this triangle right here. And we can call it triangle NQP. So we know that the interior angles of a triangle will add up to 180 degrees. So I can figure out this angle N because I know that this line segment NP bisected the original angle N. And the word bisect means that it cuts directly in half. Cuts in half. Cuts exactly in half. So if the measure of angle N is 38 degrees, I can divide that by 2. And that gives us the measure of angle N in the triangle. So I'm going to write that in black. So this is 19 degrees. And then we're going to do the exact same thing with the measure of angle P. So if we take 104 and we divide that by 2, that gives us 52 degrees. So now that we have two angles in the triangle, we can find the third angle by subtracting from 180. So I'm going to add 19 plus 52. We get 71, and I'm going to subtract 71 from 180 degrees. So then the measure of angle Q is 109 degrees. And this notation, the lowercase m, and then you have this angle symbol right here, that just says the measure of angle, and we have the measure of angle Q is 109 degrees. All right, let's look at question number 2. Question number 2 says, in the figure below, line K is parallel to line T. So I'm going to just write this right here to show that those lines are parallel. And then it says K bisects, or sorry, that's the perpendicular sign. So K is perpendicular to line Q. So here's Q and K. So they're perpendicular. That means that right here they're forming a 90-degree angle. Based on this information, which statement can be proven true? So it says angle ACB is congruent to angle ABC. So angle ACB right here is congruent to angle ABC right here. Well, they look like they might be the same degrees. However, that's not enough information to say for sure that they are the exact same. So that one might not necessarily be true. We would have to have more information in order to prove that to be true. So let's look at G. G says triangle CAB is an acute triangle. In order for it to be an acute triangle, that means that all three angles must be less than 90 degrees. So let's see if that's true. So if I see that this is 90 degrees, here, let's look at this. Okay, so if we see right here that this is 90 degrees, then I know that this right here is also 90 degrees. Angle CAB is 90 degrees, and we know that because those are corresponding angles. Corresponding angles, which basically just means that they're in the same location. And because they're in the same location, that means that they're congruent. So they're both going to be 90 degrees. So if angle CAB is 90 degrees and angle CAB is a part of the triangle CAB, then obviously there's a right angle inside of that triangle. So G doesn't work. H says angle DCB. So let me erase again just so that we can see a little bit better. So it says angle DCB is congruent to BCA. So basically this angle right here is congruent to this angle right here. And again, it looks like that could possibly be true, but really there's not enough information to tell whether or not those angles are actually congruent to each other. You would need to know a little bit more information to decide whether or not that's true. And then the last one, J, says triangle CAB is a right triangle. That one's true, and we already proved that because if this is 90 degrees right here, then this angle also has to be 90 degrees. So then that means that inside of the triangle is a 90-degree angle, so that is a right triangle. Alright, let's look at number 3. Number 3 says the equation of a line containing one leg of a right triangle is y equals -4x. Which of the following equations could represent the line containing the other leg of the triangle? Okay, so let me draw a picture so that you guys can kind of see what we're looking at. So we're looking at a right triangle. Okay, so here's my right triangle. And it says that one of the legs of the right triangle has this equation of y equals -4x. So we'll just pick a leg. Now I didn't really draw this triangle exactly in this correct position, but really just for the purpose of this question, you don't actually have to see what the triangle would look like on the x and y axis. So Then it says, which of the following equations could represent the line containing the other leg of the triangle? So if you remember, the line that's directly across from the 90-degree angle is the hypotenuse. So we're not talking about that side. We're talking about the other side, this leg right here. So we see that they're going to intersect at a 90-degree angle. That means that these two lines would be perpendicular. Perpendicular. So that means that the slope, they're going to have different slopes. So let's look at the slope of the first leg that was given to us. Our slope is -4. Well, if they're intersecting at a 90-degree angle, so they're perpendicular, that means the slope of the next leg has to be the negative reciprocal. Negative reciprocal. So, what I'm going to do is I'm going to write the first slope that was given to us, -4. I want to write that as a fraction. So in order to put a whole number as a fraction, we just need a denominator of 1. Now the negative reciprocal means that you are going to flip the numerator and the denominator, and you're going to change the sign. The word negative here just means that you are actually multiplying by a -1. So either if it was starting out negative, then you get rid of the negative sign, or if it was starting out positive, then you would add a negative sign. So here if we flip, we would get 1/4. And because it's negative, it's actually going to become positive. So this equation has to be y equals the slope 1/4 x, and then we don't really know what the y-intercept would be. So if we look at the different answer choices that we have, we know that f doesn't work because f made it negative, and it won't be negative. And if we look at the next one, it looks like G could be a good choice because we see that the slope is 1/4. H doesn't work because that's not the negative reciprocal. And J doesn't work because that's not the negative reciprocal. So the correct answer here would be G. Okay, let's look at number 4. Number 4 says, the graph of line G is shown below. Which equation describes a line parallel to line G that has a y-intercept of 0, -1? If it is parallel, that means that the slope is the same. So two lines that are parallel will have the same slope. So here, what we want to do is find the slope of this line. And there's multiple ways that you could do it. One way is to look at the vertical change and the horizontal change. So here if we're looking at what's happening, and it's a little bit hard to see because the graph is so small, but remember that slope is the vertical change over the horizontal change. So here I go down 1, and then I go right 2. Down 1, right 2, down 1, right 2. That's the pattern. So if I'm moving down, that's going in the negative direction, so down 1, and then to the right 2 would be a positive 2. So my slope of this line, the slope of line G, is -1/2. Now let's say you didn't remember how to do it that way. Let's say you wanted to look at the ordered pairs that were given. Slope is y2 minus y1 over x2 minus x1. So let's say that this is my first point and this is my second point. So y2 would be 2 minus y1 of 6, and then x2 would be 4 minus x1 of negative 4. So that's the same as 2 minus 6, which is negative 4. And then here when you're subtracting a negative, that is really just adding the opposite. So here we're actually adding these numbers. So 4 minus a negative 4 is really just 4 plus 4, which gives us a denominator of 8. So then if we simplify, we can simplify the numerator and denominator by 4 to get negative 1/2, which is what we got right here. But I was just showing you an alternate way to get the slope. Okay, so it says which equation describes a line parallel to line G with a y-intercept of 0, -1. So let's look at whichever answer choice gives us a slope of negative 1/2. A doesn't work. B doesn't work because that's a positive 1/2. C works, and it has the y-intercept of -1. D doesn't work. So the correct answer is C, because our slope is negative 1/2. And if they're parallel, then they have to have the exact same slope. Alright, let's look at number 5. Number 5 says the slope of sides of quadrilateral ABCD are shown in the table below. Which statement describes the relationship between the sides of the quadrilateral? Okay, so this kind of goes over some of the same questions that we were just looking at. So if it is parallel, then they have the same slope. That's important. This is so important to remember. And then the other one is that they are perpendicular. Perpendicular lines will have the negative reciprocal. So for example, right here, line segment CD and line segment AD, I know that those are perpendicular to each other because they have a negative reciprocal slope. So their slope, all you do is flip the numerator and denominator, and then you make it negative or make it positive. Okay, so let's look at the answer choices. You might have already figured it out by now. So it says AD is parallel to BC. Well, if they were parallel to each other, then they would have the same slope, and they don't. So A doesn't possibly work. AB is parallel to CD. That's true because they have the same slope. And then it says, but AD is not parallel to BC. And that one's true also because AD, if they were parallel, they would have the exact same slope, and they don't. One has the 5 in the numerator and the 2 in the denominator. So those do not have the same slope. B is the correct answer. Number 6. So here, this kind of goes step by step on right here. These 2 points go step on step to tell you how to solve this one. So let's go ahead and look at it. So we're basically finding the measure of angle 1, 2, and 3. So it says you know the measure of two angles in one triangle and one measure of another. You also know that angle ACB and angle 2 are vertical angles. Vertical angles are congruent. That means they equal each other. They'll have the same measure. So automatically we can see right here, I don't know if that's hard to see. Automatically we can see right here that angle 2, the measure of angle 2 has to be 78 degrees since they're vertical angles. Alright, so it says find the measure of angle 3 using the triangle sum theorem. That's just a fancy way of saying that the interior angles of a triangle add up to 180 degrees. So let's go ahead and do that. If we know angle A and angle C, we can add those two together and then subtract from 180. So when we subtract from 180, we're going to get 82 degrees. So 82 degrees would be the measure of angle 3. Now let's find the measure of angle 1. So it says use the vertical angle theorem to find the measure of angle 2, which we already did. Then you will have enough information to find the measure of angle 1 in triangles CDE. So we're going to follow the same steps. We know two of the angles. So we're going to add those together. And then we're just going to subtract from 180 degrees. So then that gives us the measure of angle 1 is 41 degrees. Alright, let's look at number 7. Number 7 says find the measure, or find each measure. Okay, so we'll start with finding the measure of angle 1. So the measure of angle 1, we know that this symbol right here means that it's 90 degrees. And if we have two angles inside of the triangle, we can find the third angle by adding the two angles that we know and then subtracting from 180 degrees. So then that gives us that the measure of angle 1 is 61 degrees. Now we can find the measure of angle 2. So if you look right here, the 29 and angle 2, those are a linear pair. Linear pair. So what that means is they are on the exact same line. They're adjacent to each other. If they're on the same line, that means that they're going to have a sum of 180 degrees. They're supplementary. So I'm going to subtract 29 minus 180 degrees. And I get 151 degrees. So then the measure of angle 2 is 151 degrees. Alright, now let's solve for the measure of angle 3. So we know two of the angles inside of the triangle. So that's going to allow us to find the third angle. So we can add 151 plus 17. That gives us 168. And then we're going to subtract from 180 degrees. So we get that the measure of angle 3 is 12 degrees. I should have mentioned this at the beginning of the video, but I tend to go kind of quickly because I don't want the video to run too long, and I can already tell that it's going to be super long. So please pause and go at your own pace so that you don't feel like I'm moving too quickly. All right, let's look at number 8. Number 8, we're finding the measure of angle 1, 2, and 3. Now I want you to notice here on angle 1, we have one arc symbol here, and angle 2, we have another, well, the same arc symbol. And because they both only have one arc symbol, that means that they're the same measure. So angle 1 is congruent to angle 2. So that means that they're, whatever degrees they have, they're going to be exactly the same. And let me just show you what I mean. Like let's say, for example, so here, so let's say this is ABC. The measure of angle A would be congruent to the measure, oops, okay, so it's congruent to the measure of angle C, and that's just according to the picture that I drew. But we see that angle B is different because of the amount of arcs that you see. So like here, because we see 2 arcs, that means that they're going to be different. Now hopefully you already knew that, but I was just explaining that to clarify. Alright, let's look at going ahead and solving these angles. So probably the easiest right now to solve for would be the measure of angle 3. So we're going to add the other 2 angles that are inside triangle WXZ. So we're going to add 23 plus 24, so that gives us 47 degrees. And we're going to subtract that from 180. Oops. So we get 133. So the measure of angle 3 is 133 degrees. Now to find the measure of angle 1 and angle 2, we're going to need to use some algebra. So I'm going to say that the measure of angle 1 is x, and the measure of angle 2 is also x, because we know that they're congruent to each other. Now we know that the 3 angles inside of the triangle have to add up to 180 degrees. So that means 105 plus x have to add up to 180 degrees. So let's simplify the equation that I just wrote down. So here when we combine, x plus x is 2x. Now I want to solve the two-step equation, so I'm going to subtract 105 from both sides. And we get 75. So now I want to divide by 2. So we would do 75 divided by 2. That's going to give us 37.5 degrees. So the measure of angle 1 and the measure of angle 2 is 37.5 degrees. Alright, let's look at number 9. So number 9 says find the measure of each numbered angle. So let's go ahead and start by finding the measure of angle 2. So we know 2 other angles inside of that triangle. So we can add the 2 angles that were given and then subtract from 180 degrees. So we get that the measure of angle 2 is 52 degrees. Now let's find the measure of angle 1. And I want you to realize that on these problems, there's really a lot of ways that you could solve. So like, for example, right now we could even solve for the measure of angle 3. And let me show you how. Let's say that we're just looking at the really big triangle and forget that there's that line in the middle making two triangles. Let's just pretend that there's one triangle. So if we look at triangle JKM, we know that the measure of angle K is 99 degrees. Where am I getting that from? Well, here, if I add 71 plus 28, we get 99. And the measure of angle M is 52 because we just solved for it. So then to find the measure of angle J, I could add these two together. And then I can subtract from 180 degrees. So that means that the measure of angle J, or actually, let's go ahead and show that that was actually angle 3. So the measure of angle 3 is 29 degrees. So that was another way that you could have solved. I mean, there's multiple ways to solve these problems. That's what's so beautiful about math. Okay, so here, to find the measure of angle 1, you can recognize that that is a linear pair. That means that they are supplementary. So if I subtract 57 from 180, we're going to get 123. So the measure of angle 1 is 123 degrees. Okay, last question, number 10. If two sides of a triangle measure 7 and 23, the third side must be between what two numbers? Okay, so whenever you're creating a triangle, there are, I guess, let's say that there's 3 things that could happen. Okay, one, the first thing that could happen, and what you hope to happen, is that you successfully create a triangle and it looks beautiful and all the sides connect. The other thing that could happen is that you could have these 2 sides of a triangle and then the third side is way too short and then they don't connect and this is not a triangle. And then the third thing that could happen is that you have these 2 long, beautiful sides, and then you have this third side that is way too long. That's not a triangle. So your goal is to create a triangle. So if you know that 2 sides are 7 and 23, that means that the third side must be less than the sum of the 2 sides. So if we add these together, that gives us 30. So the third side has to be smaller than 30. It has to be less than 30. And then the third side has to be longer than the difference of the 2 sides. So if we subtract, so 23 minus 7 is 16. So it has to be longer than the difference. Okay. So if we wanted to write this inequality, let's say that the third side is x. We know that x is going to be between 16 and 30. So 16 is less than x is less than 30. So here you could say that it's between 16 and 30. All right, I hope that was helpful.